Scout TIA Getting Started. In this tutorial, we will show you how to create a simple sample project with the Simotion Scout TIA engineering system. If you want to start immediately with the tutorial, select Simotion Go's TIA portal in the right-hand section of this window. If you want to know how to use this tutorial, select How do I use this tutorial? You require approximately 1 hour to work through this tutorial. The Simotion team wishes you a lot of fun and success learning about Simotion Scout TIA. You use mainly the following operator controls in this tutorial. The navigation. This is in the top left-hand corner of the window. With the navigation, you can always see which part of the tutorial you are currently processing. Click in the navigation field to open the table of contents. Click the red triangle to open individual chapters. There are further controls in the top right-hand corner. The red status bar shows the present progress in %. Click the house icon to return to the start of the tutorial. If you click the loudspeaker icon, the tutorial is muted. You can use the red arrows to jump back and forward to the previous scenes. You can select the desired language for the player and the contents under Settings. 2 languages are available, German and English. The section bar is located in the bottom section of the tutorial to show in which section of the scene you are at present. The operator controls are at the right-hand end of the section bar. A scene generally has several sections which are played in succession. You can jump to the individual sections, pause the tutorial or replay it using the operator controls. There are further operator controls in the bottom right-hand corner as well as a display of the current scene number. The scene number indicates the scene which is currently being displayed and the total number of scenes in the tutorial. You can jump to the previous scene or the next scene with the red arrows. And finally, please also note the following. In the overview scenes, links to external sources or references to other chapters can be integrated on the right next to the display text. Simotion is a motion control system that is currently implemented in all industrial sectors with ready-made solutions for the entire drivetrain. Siemens has integrated this successful system in the TIA Portal engineering framework. This makes the planning, commissioning, and operation of complex systems even easier, quicker, and this tutorial introduces you to working with the Simotion Scout TIA engineering system. You will create a simple sample project and run through the typical configuration steps. First, you create a project. You then create a Simotion device and set up the network communication between the programming device and the Simotion device. In the next step, you commission the drive and configure it. You then set up an axis, interconnect the axis to the drive, and test the axis with the axis control panel. You also configure inputs and outputs for the sample program, which you create to control the configured axis. You then write a simple user program and monitor the program-controlled axis motion. The requirements that apply for this tutorial are described in the next section. To create the sample project, you require a training system with a few components. You require a programming device with a free Ethernet interface. In addition, a Simotion device with the latest firmware and memory card, as well as a Synamics drive with infeed, motor for operation of an axis and supply for the motor. The motion control hardware components must be wired via the drive-click interface. The programming device must also be connected to the Simotion device via an Ethernet cable. You have also installed the TIA Portal and Simotion Scout TIA on the programming device and have opened the TIA Portal. When these requirements are satisfied, you can start to prepare your configuration. In the following section, you will learn how to prepare your configuration. We will show you how to restore the Simotion device to the delivery state. For the sample project, it is useful to reset the Simotion device to the delivery state. In this way, you restore the default communications parameters and you delete user data loaded to the device and the memory card by a previous configuration. The runtime licenses are retained. You restore the Simotion device to the delivery state as follows. First, switch off the power supply of the Simotion device. Then, set the mode selector switch to position 3. The rotary switch can be destroyed by static electricity. Therefore, operate the rotary switch only with an insulated screwdriver. Switch the power supply on again. The factory settings are loaded. Wait for the procedure to finish. The elements on the front of the module indicate completion. The 7-segment display shows status 6, which means that the device has powered up. The top LED flashes green. In this case, the drive is ready for commissioning. And the stop LED is yellow, indicating that the device is in the stop operating state. Then, set the mode selector switch to position 0. The Simotion device has been restored to its factory settings and is ready for commissioning. You can now start with the configuration in Simotion Scout TIA. In this section, you create the sample project Sample 1 in the TIA Portal. All of the subsequent configuring steps refer to this sample project. After opening the TIA Portal, you are in the Portal view. You create your sample project here. The Portal view offers a task-oriented view of the tools and provides the basic functions for the individual tasks. You start a new configuration by creating a new project in the TIA Portal. To do this, click the entry to create a new project in the Portal view. Enter the desired project name. Using the appropriate button, enter the path in which the project is to be stored. The default path is already set. Then, confirm your configuration. You have created the sample project in the TIA Portal. You can now start with the configuration of your Simotion device. This section shows you how to create a Simotion device in the TIA Portal and how to set up the communication between the programming device and the Simotion device. Simotion D is the drive-based version of the Simotion motion control system based on the Sinamics family of drives. With Simotion D, the Simotion motion control functionalities and the Sinamics drive software run on a Sinamics-type closed-loop control hardware device. Now create a Simotion device in the TIA Portal. Proceed as follows. Open the dialog to configure a device. Then click the Add New Device entry. Select the required device version. Select the firmware version of the device. Note that the selected firmware version must be identical to that on the CF card. Otherwise, an error message will appear as soon as you switch to online mode. Confirm your configuration. After you have created the device, you will be in the device view of the project view. The Simotion device is displayed here realistically and can be configured. In the next step, you change to the network view in order to create an Ethernet subnet. You set up the online communication of the programming device with the Simotion device via Profibus, Profinet, or Industrial Ethernet. In this example, you configure Industrial Ethernet, the most frequently used application in industry. To create an Ethernet subnet, first switch to the network view. Then, select the X127 Ethernet interface. Create the Ethernet subnet via the shortcut menu. The Ethernet subnet is then displayed immediately in the network view. You can now set up the network communication between the programming device and the Simotion device. Assign the Ethernet interface in this section. Various options are available for assigning the interfaces. The following procedure describes the process using the Go Online function. Establish an online connection to the Simotion device. Select the interface type and the Ethernet interface of the programming device. Also select the created subnet. Then select the Simotion device and confirm your configuration. If you have not already assigned an IP address to the programming device, you will be prompted at this point to assign a suitable IP address temporarily from the subnet of the device. The online connection to the Simotion device is established. This is indicated by the orange color of the title bar in the project view. This completes the configuration of the Simotion device and the network communication. In the next step, you download the hardware configuration to the target system. Before you continue the configuration in the Simotion Scout TIA, download the hardware configuration from the TIA portal to the Simotion device. First, disconnect the online connection to the Simotion device. In the next step, compile the hardware configuration. The process is logged in the Compile tab. Download the hardware configuration to the target device. Confirm your selection. You have successfully downloaded the hardware configuration to the Simotion device. Now, open Simotion Scout TIA and configure the drive. In this section, you configure the integrated drive of the Simotion device. For this purpose, you use the Auto configuration, through which all components with a drive click interface, such as an infeed, are also created. The speed and current for controlling the motor are regulated in the drive. Simotion Scout TIA can read out the electronic rating plates of the Synamics drive components online via the drive click interface and can use this data to configure the drive automatically. To start the drive configuration, first open Simotion Scout TIA. Then, activate the communication between the programming device and the Simotion device. In the following dialog, activate the configured Simotion device and the integrated drive and confirm your entries. Now call the automatic configuration. Confirm the prompt regarding restoring the factory settings with Yes. In the Open dialog, you can specify whether you are using a drive object of the servo or vector type. Select servo and confirm your selection. The automatic configuration is started. If the firmware version on the DriveClick components is different to that on the CF card, a firmware update is performed automatically at this position. In this case, proceed as follows. Wait for the procedure to finish. This can take several minutes. You must then change to offline mode. You must also switch the power supply to the Sinamics components off and then on again. If a firmware update has not been performed, remain online to be able to see the changes in the project tree. The drive detected by the auto configuration is displayed in the project tree below the integrated drive. Then, open the System folder for infeeds. If you are using an infeed with DriveClick interface, the infeed is created there. If you are using an infeed without DriveClick interface, configure the infeed manually. Further information on this topic can be found in the Simotion Scout TIA Getting Started online help. The drive is therefore ready for operation and can be interconnected to an axis. This section shows you how to create and configure an axis in the project and how to interconnect it to the integrated drive of the Simotion device. Simotion Scout TIA provides the Axis Wizard for this purpose. The Axis Technology object represents the respective real objects in the controller, for example, a position axis. This technology object contains an extensive functionality. It executes control and motion commands and displays states and actual values. For the sample project, create the Axis 1 axis. To do this, use the wizard provided by Simotion Scout TIA. First, change to offline mode. To open the Axis Wizard, double-click the appropriate entry in the Project Navigator. Assign a name to the axis in the Name field. Use the name Axis 1 for the axis of the sample project. Define the axis type. Select preferably a linear axis with an interconnection to an electrical drive. Assign the axis to the drive that you have already configured. In the dialog for the encoder assignment, use the motor encoder connected to the drive as the default setting. The Axis Wizard then arranges the configuration data in an overview. Close this dialog. You have now created an axis. No further configuration is required for the sample project. Save and compile the changes and go online. Then, download the project with the axis configuration to the target system to be able to test the functioning of the axis in the next step. If you want your project to be stored protected against power failure on the CF card, activate the appropriate checkbox in the Open dialog and start the loading operation with Yes. Simotion Scout TIA performs numerous tests that are logged in the Detail view. The green color of the connector icons on the Simotion device and on the integrated Sinamics drive indicates that the project data in the programming device is identical to the project data in the target system. All the requirements are therefore satisfied to test the axis with the Axis Control Panel. In this section, you test the configured axis. Simotion Scout TIA provides the Axis Control Panel for this purpose. The Axis Control Panel is used for controlling and monitoring individual axes. You can use it to traverse axes together with the drive. You can use the control panel for the following tasks, for example. Test axes before you traverse them via a program. Test whether the axes can be traversed using the control panel when a fault occurs, or also set and remove an axis enable. In the sample project, you traverse the setup axis in a jog mode to test the correct functioning of the axis. Open the Axis Control Panel. The Axis Control Panel opens in the Detail view. The Detail view can be maximized in Simotion Scout TIA for user-friendly configuration. To be able to traverse the axis, the programming device must obtain control priority. Click the corresponding button. Read the safety instructions carefully and then confirm the dialog. Then set the axis enable. Click the Home Axis icon. Set the Set Home Position homing type in the opened dialog and enter the value 0 at Home Position Coordinate. Confirm your entries and start the homing of the axis. Call the dialog for position-controlled traversing of the axis. Specify the velocity of the axis here and confirm your entries. Now try to traverse the axis in jog mode. The axis will be traversed as long as you press the switch. You can monitor the traversing motion in the velocity and position fields. Then, remove the axis enable. If you want to traverse the axis again, acknowledge all alarms in the Alarms window. Then, close the Axis Control Panel by returning the control priority and changing to offline mode. You have now successfully traversed the axis of the sample project with the Axis Control Panel and thus ensured its correct functioning. In the next step, configure the digital outputs available on the Simotion device that are required for the user program. In this section, you configure two of the digital inputs and outputs available on the Simotion device as outputs. You require the outputs for the program that you will write in the subsequent configuration step. You use the digital inputs and outputs of terminal X142 for the sample project. These channels are permanently assigned to Simotion D. The terminal is therefore visible in the project tree below the Simotion device. You configure the digital outputs in the TIA portal. You can open the TIA portal by simply double-clicking the terminal in the project tree of Simotion Scout TIA. The TIA portal automatically opens the tab with the property. In this section, you configure the digital outputs in the TIA portal. You can open the TIA portal by simply double-clicking the terminal in the project tree of Simotion Scout TIA. The TIA portal automatically opens the tab with the properties of the SIMOTION device. You can configure the required outputs here. Obtain more space for easier configuration by double-clicking. Then, open the area for configuring the digital outputs. Terminal X142 is shown here with the specification of the terminal numbers and the current use of the channels. All channels are factory set as digital inputs. Define channels 0 and 1 as digital outputs. Then, save the project. You have now finished with the configuration of the digital outputs. Next, you can write your own SIMOTION program. In this section, you write a simple user program for the sample project. To do this, you create the variables required by the program and create the program and additional utility programs with the graphic editors provided by SIMOTION Scout TIA. The program which you create in the sample project is to control the axis that has been set up. The axis is to traverse to a specific position and return to the original position. Before we start with the programming, the principal structure of a SIMOTION application is explained in the following. First of all, you create two global device variables which describe the program states program started and end of program reached. Global device variables are user-defined variables with a limited scope of validity. All programs of a SIMOTION device can access global device variables. You also require two I/O variables. These variables apply the program state to the configured digital outputs of the SIMOTION device, for example, for a display. An I/O variable is a symbolic variable name that is assigned to an I/O address of the SIMOTION device or to the I/O. If you are using an in-feed with drive-click interface, also create two additional I/O variables to control the in-feed and query the status. You use these variables in the Motion Control Chart program to control the axis that you have set up. Motion Control Chart is a graphical programming language. The programmed motion sequences are displayed here as flow diagrams. You create an additional program sequence for the in-feed with drive-click interface which switches on the in-feed before the axis commands are subsequently issued. The execution system that you also configure in the sample project requires two further motion control programs. These programs process system events such as axis alarms or I/O alarms. No special processing is required in this sample configuration, and therefore the programs can remain empty. If no programs are assigned to the system events, the CPU goes into the stop operating state when these events occur. You then write a program in which the global device variables are read cyclically and the I/O variables set accordingly. In the next step, you assign these programs to the tasks of the execution system. You create global device variables in the symbol browser of the detail view. Proceed as follows. Click the appropriate entry in the Project Navigator. In the Name column, click the first empty cell and enter the desired variable name. Then select the data type. Tip: if you press the Return or Tab key, the input focus jumps to the next field. Create the second global device variable that you require for the sample program in the same way. You have now created two global device variables. You still require 4 I/O variables which you create in the address list. Proceed as follows to create the I/O variables. Call the address list in the Project Navigator. In the Name column, click the first empty cell and enter the variable name. Then, select the keyword OUT in the relevant column. You can also select the data type or leave this field empty. Assign the configured digital output to the variable. To do this, call the Assignment dialog. Open the PLC1 element in this dialog and select the required digital output. The digital output is assigned to the I/O variable. Then, confirm your entries. Create the second I/O variable in the same way and assign it to the configured digital output D01. If you are using an infeed with drive click interface, create two additional I/O variables. Define the first variable as an output variable and assign this variable to the control word of the infeed. To do this, open the Synamics Integrated 1 element. Define the second variable as an input variable and assign it to the status word of the infeed. The declaration of all variables is complete. Now use the variable to create a simple user program. You create the MCC unit motion for the sample project as follows. In the Project Navigator, open the Programs folder below the Simotion device. Insert an MCC unit. Enter a name for the program. Also, activate a few useful options for diagnostic purposes, which allow you to monitor the program execution in online mode. Confirm with OK. The MCC unit is displayed in the Project Navigator below the Programs branch. The declaration table of the unit opens in the Working area. No other variable declaration is required for the sample project. Create a motion control chart in the next step. In the following, you create a motion control chart within the motion unit. First, call the dialog for creating an MCC chart. Enter the desired name for the chart. The MCC chart should be of the program type. Then, confirm your configuration. The motion control chart is displayed in the Project Navigator below the motion unit. The MCC editor is also opened with the predefined start and end nodes. You can now start with the programming. First, set the global device variables already declared in your program to a defined initial state. Mark the connecting line between the start and end nodes and then insert the variable assignment command block via the basic commands of the motion control editor. Double-click this block and select the value Formula in the drop-down list. Call the symbol browser with the global device variables. If you have closed the detailed view, open it again via the menu bar of Simotion Scout TIA. Select the desired variable and drag it to the variable column in the Variable Assignment window. Initialize this variable with the value false. Also initialize the second variable. Select the value true and confirm your entries. You have now performed the variable assignment. Next, insert a command block for the axis enable. To traverse the axis, you must first enable it. To do this, also insert a command block, but this time from another command group, the single axis commands. The block that you have selected is created in the editor. You must now parameterize this command. In the opened dialog, select the axis to be controlled from the program. Confirm with OK. The command is also parameterized. In the next step, insert a block to home the axis.